Lesson 2.9, Weighted Averages. Please write down this definition. Weighted averages. A weighted average is the sum of the product of the number of units and the value per unit divided by the sum of the number of units. So weighted averages are used for different types of problems. One type of problem that uses weighted averages is a mixture problem. When you have a mix of things that become one thing, a mixture problem. Number one is a mixture problem. Let me read this for you. You don't have to copy down the problem, but we are going to work it out together, so you are going to work it out in your notes. Okay. Number one, a tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Okay, so the first thing you need to look at or to define is what is it that we're looking for? What is my unknown? And so my unknown is how many pounds of black tea should be added. So let's go ahead and assign a variable to that. This is going to be the variable W. We'll call that W. All right, so as the problem tells us, it takes 2 ingredients to make this mixture, right? We have the dried blackberries and we have the black tea. And together, when you add them together, you will wind up with blackberry tea, the mixture. Okay, so you're doing this with me to practice how we find the weighted average needed and solve an equation. Okay, here we go. Number of units. We're going to be using 5 pounds of dried blackberries, and we don't know how many pounds of black tea. But we know that for the tea, we're going to wind up with W plus 5. Because remember that we are mixing these 2 ingredients together. We're adding them together. Okay? All right, let's look at the price per unit. Okay, so we know that the dried blackberries are $10.50 per pound, and we know that the black tea is 35 cents per pound, and we want a mixture that costs $25 per pound. Okay, so we want to blend these in the way that we'll wind up with a $25 per pound price. Okay, total. We have 5 pounds at $10.50 a pound, and we have W pounds at $35 a pound. Okay, so as we multiply across on this third one, for the tea, it's $25 times W plus 5. So what we're going to do is we're going to use this column right there to write our equation. Okay, it tells us that the price for the blackberries is 5 times $10.50 plus the price of the black tea is 35 times W, has to equal 25 times W plus 5. And now we can simply solve for W. Okay, so let's do that. First thing I'm going to do is simplify. 1050 times 5 is $52.50 plus 35W equals, let's distribute the 25. So that would be 25W plus 125. Okay. The next thing we'll do is get the W's on one side. So subtract 25W from both sides. Here we go. So we have $52.50 equals, plus 10W equals 125, and let me put the decimals there to help you. Okay, we will subtract 52.50 from both sides. So we have 10W equals 72.50, and we'll divide by 10. Divide by 10. I've got to move over here. I'm sorry, I ran out of room. But W equals 7.25. So because we're looking for how many pounds of black tea, the answer would be 7¼ pounds, 7.25 pounds. So for each problem, you will have to write a table like this. Extend number of units times price per unit to get a total, and then from the total, write your equation and then solve. Okay? All right, let's look at number 2 together. Here we go. Mrs. Matthews has 16 cups of punch, that is 3% pineapple juice. She also has a punch that's 33% pineapple juice. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that is 20% apple juice? This is also a mixture problem, but now this time we're not talking about prices, we're talking about percentage of one of the ingredients. Okay, so let's look at what is our unknown. We're looking for how many cups of the 33% punch will she need. That's going to be our variable. And I guess we can call that, we'll call that X. Okay. All right, so what are we going to mix together? There's two kinds of punch that she has. She has the 3%, we'll call it the 3% punch. That's the one that has only 3% pineapple juice. And then she has 33% punch. That's what she has. And she's going to mix them together. And she wants to come up with a 20% punch. That's what she wants. All right. So let's see how many cups of each she has. Number of units. All right, so it looks like the 3% punch, it tells us she has 16 cups. The 33% cup punch, that's our X. And when we add those together, we know we'll have X plus 16. And then here, percentage of juice. I know I have the 3% punch has 0.03 times 16 cups. That's how much juice is in those 16 cups. And this one, 33% is 0.33 times X, because we don't know how many cups of that juice we have. And we know that our total needs to work out to be 0.2 2 times x plus 16. So once again, we're going to work with this column to come up with our equation. It looks like this. I'm going to mix together 0.03 times 16, my 16 cups of 3% punch, together with I don't know how many cups of my 33% punch, okay? And then that has to equal my 20% punch, 0.2 times x plus 16. Okay, now let's solve. Okay, so 3% times 16 is 0.48 plus 0.33x is equal to 0.2x plus 3.2. Okay, so I have x's on both sides. Let me go ahead and subtract 0.2x from both sides. 0.2, I'm going to put a 0 there to hold a place value. Alright, so I come up with 0.48 plus 0.13x is equal to 3.2. Alright, let's subtract 0.48 from there, and let's subtract it from here. I'm going to put a 0 there just to hold my place. Okay, so I'll have 0.13x is equal to 2.72, and then I'll need to divide both sides by 0.13, 0.13, and so I have 20.923, and it continues, but I guess we would, if it tells us, it doesn't tell us what to round to. I guess if it doesn't tell us what to round to, we can round to the whole number, and it would be 21 cups. We would need 21 cups of the 33% punch to mix it together with 16 cups of the 3% cup punch to come up with a 20% mixture. Okay. All right, so another type of problem that we use weighted averages for is for motion problems, rate problems like this one. Let's look at this one. It took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30 minutes. What is the average speed of their trip? So what we know is that they traveled 5 miles in their going and 5 miles in their return. Okay, let's just think back for a moment. Let's do this real quick. Distance equals rate times time. So that's the formula that we're going to use here. Distance equals rate times time. And so we know that if we wanted to solve, because of course we're looking for the average speed, that's what we want to know, the average speed of their trip this time. So if we're looking for the average speed, what we have to do is we have to add the rate and the time of their going, rate times the time of their returning, and we have to add those and then divide it by how long it took them to go and to return. Okay, so before we can do that, we need to determine their rate as they were going, and their rate as they were returning. So let's first look at the rate at which they were going. Okay, it took them 5 miles It took them 40 minutes to skate 5 miles. So, distance equals rate times time. What we want to do is solve for rate. Let's use what we learned in the last lesson. Let's solve this equation for R. Okay, so we would have R equals T divided by, D divided by T. D, distance, divided by T. And the way I did that is I divided both sides by T to get R alone. So, in going, the rate